hopefully we're streaming to the YouTube, the YouTubingtons. And let's see if we are. Okay, we are. Nice. Hopefully the audio is being picked up. Love the intro song. Thanks so much, Sweet. Love the Beatles. What's up, Generous Kid? Hey there, June. You say goodbye. I wish I could play. How do I, like... Could we figure out, like, how to get, like, a Discord bot that can play songs in here? Could we figure that out? I really want to get that going. Because I want to, like, play, like, intro songs as people come in. You know? Is that possible? I don't even know. Also, wait, I realized that I probably can't hear anything because my audio is messed up. Wait, hold on one sec. Okay. I feel like my audio... okay. Oh, it is messed up, that's why. I see. Okay, cool. All right. Yeah, sweet. How do we get like a Discord bot that can do that? I don't even know. We gotta get one though. We got Boaz, IT Guru in the house, the new playground master. What's up, Boaz? I don't know either. Aw. Just working the elevator? That's awesome. I love you're tinkering with that. Could you imagine how awesome it would be if Emerald City, or like us as a group, came out with a new playground, and we just like overtook the current playground? That'd be such a power move. Yeah, we can ask Vivian or Claire. Yeah, we should.
Yeah, this 100% will if we get it working right.
Yeah, I absolutely love that. I think if we do, it would be such a power move because we could just tell people to use it instead, and we could put like Emerald City branding on it, and it would be dope. And also because it works with testnet and mainnet too.
Yeah, well, and then I was even thinking like as a great intermediary, we should set up like the next Academy workshop to run through it because then it can just save everything for us and even have it create the GitHubs for people and stuff.
Oh, totally. Yeah, I mean, you're just a straight legend. I think this is gonna be really cool if we get it to work. And also, just as a side note, if you need any help figuring out like how to deploy contracts, like, because you know how on the playground you click deploy and it like will run a transaction, deploy contracts. If you need any help with that stuff, I'm really good at that. So if I don't know if that helps or not, but I'm definitely happy to help there.
Definitely. Once we get there.
Yeah, totally. What's up, Becca? Uh-oh, we got Becca. Bam, what's up? UAD, good to see you. JT is living the dream. I always love the name because my name is JT. Opal Hunter, how you doing? Ricardo, thanks for joining. Ricardo, Snowmobiles, Bam, you've all been doing such an amazing job reviewing quests. Thank you so much for doing that. And we love you for it. Do you even sleep? Didn't you finish the session of Blocked Out? Yeah, so I went to bed at 4 in the morning, and then I had to wake up an hour and a half later. So I got an hour and a half of sleep, woke up at 5:30, did the Blocked Out session, and then I've been up ever since, just working on stuff. Trooper, I know. What can I say? What can I say? Just a legend. Yeah, how do we get the I'm telling you, we need like a Discord bot in here. We need one because I want to play some Beatles songs as people come in here. Anyway, are we already at 12:03? Okay, this is crazy. Anyways, yeah, so I'm back. I know you all know this, but I'm back in New York now. And I'm finally at a computer I can actually record with, so man, just wait till you have kids. I've been running like 3 to 5 hours of sleep at night right now. Wow. That's crazy, actually. That's actually crazy. Yeah, that was pretty much, I'm sure it's a lot worse, but that was pretty much me when I was doing school and Emerald City and working my other job. It was traumatizing. But now that school's over.
I'll take work and the school over all of that with 2 kids under 3.
Yeah, I would too. I trust you on that. SDD's Me6, yeah. Although, didn't Me6 just get hacked recently? Revolution number 9 welcome song? Yeah, we'll play some anime music too. What's up, Captain Cook? Hey, Crypto Chica. Thanks for joining. All right, we're gonna get started. I love this part of the workshop where we just get to talk, but we got some stuff to do. So with that being said, I'm gonna share my screen, and yeah, so we're gonna be diving into some other concepts today. So if you were confused already about resources, I'm sorry. We're going full force into some other concepts. So I guess like really quickly, how is everyone doing with the boot camp? Is everyone like understanding resources, catching up a little bit, maybe a little confused still? Everyone doing all right? All right, Crypto Chica's doing all right. That's good to hear. That's really good to hear. Will we catch him this weekend? All right, nice, nice. Wild Turkey said, "Yep, just being a sponge." All right, cool. Yeah, so the goal here is to talk a little bit more about resources. We're going to talk about something called access control, which is another big concept. And then this weekend, all you guys can sort of hit the books, watch this over, read the content. Hopefully, you'll catch up by next week. She's been playing League slacker. Wow, what a slacker! Yeah, Becca's been playing some Enchanter support, which I need a good Enchanter support in my life because I'm playing AD carry and my supports stink. All right, so we're back for another day. We're on Chapter 3, Day 4, and we're going to talk about resource and struct interfaces, all right? So in the previous workshop, we went over resources, right, which is really cool. We talked about how they're sort of like NFTs. They're like assets. They contain data, but they're also like, valuable, right? So we went over what resources are. But in today's lesson, we're going to go over resource and struct interfaces. So first of all, what the heck is an interface? Well, an interface is something that specifies a set of requirements for something to implement. And second, it allows you to only expose certain things to certain people. So they're used for two different things, right? I just talked about both of those, but it's kind of abstract. So we're gonna go through each one of these, right? It's a set of requirements for something to implement, and then it allows you to only expose certain things to certain people. We're gonna go over both of these separately to help you understand. So when you think about an interface, right, you have a resource or a struct, right, in this blue box, and then think of it almost like the resource or struct implements the interface, okay? So the interface is sort of sitting on top, almost like a hat, and the resource or struct decides to wear that hat, okay? And that's what it's sort of like from a more visual point of view. But let's dive into some code. I apologize. I'm going to also keep coughing because I'm somehow still sick. I don't know what's going on. All right, so let's clear some stuff in the playground. Let's clear all this fun jazz, and then here, let's say public resource test. And then here, we're going to put like a public let ID. And we're going to put like a public let name just to put some random fields in there. We're going to initialize our resource to say self.id equals ID and self.name equals name. All right, let's go ahead and make these two variables a thing. And this is all stuff that we've done before. So if you should understand it, but if you don't, that's okay. I'm sure you'll get it at some point. But anyway, we made a resource. Let me make this a bit bigger so you can all read it. And hopefully you can all see it pretty clearly now. Okay, cool. Awesome. So what is an interface? Well, I'm just going to go ahead and make an interface, all right? And you're not going to understand what it does yet or what it means, but let's just go ahead and make it so you can see it. A interface is where you say public resource interface, and then usually in computer science, there's different standards, but usually what you do with an interface name is you prefix it with the capital I, which stands for interface. So I'm going to call it iTest, all right? At least that's what I do. You'll see this a lot in Solidity, which is the smart contract language for Ethereum. Not as much for Flow, but I still use it in Flow because it makes the most sense to me. It's up to you how you want to name them, but I just put an I in front of it because it's an interface, all right? So, little disclaimer or just side note, this entire lesson, I'm going to be using resource interfaces, but this is the exact same thing for structs. So if I made a public struct test, then the resource, the interface would be a public struct interface iTest. Okay. So it's the same thing. I'm just going to use resources for today's lesson because we recently talked about them, and they're, you're usually going to see resource interfaces anyway. So what is the first thing saying? Well, what is an interface? Okay, so what's the first thing? It specifies a set of requirements for something to implement. All right, let's read that again. It specifies a set of requirements for something to implement. Okay, cool. So in this interface, let's say I have a public let, I don't know, greeting. All right, and it's a string. Now, the thing about an interface is that you never initialize the values. And the reason for that is because an interface is not an actual thing. It's a piece of code that tells another piece of code it has to have it, or it has to have certain things that it defines. So you're never going to make an iTest, right? You know how with a resource, we create the resource called test, we pass it around, we store it, we destroy it, all that kind of stuff. An iTest or an interface is not an actual thing. It's an abstract idea of what a thing is. So in this case, we don't have to initialize greeting because it's never going to actually have a value. It's just this iTest, all we know is that this iTest interface has a value called greeting, all right? And so what's going to happen if, see this arrow where the resource implements the interface? Well, right now, the test resource it has no relation to iTest, right? They're just code that's next to each other in space. There's no actual relation. The way that you make test implement iTest is you do this little thing. You put a colon and then the name of the interface, iTest, like that. And so you'll see that we automatically get an error here, and that's because of this first thing, right, of what's an interface. Well, it specifies a set of requirements for something to implement. So iTest is saying, whatever implements me, it has to have a greeting, right? And right now, we said that test implements iTest. But the problem is that test doesn't have a greeting inside of it. So there's a problem, right? So we have to say public let greeting is a string, and then self.greeting equals greeting. And we can go ahead and make another greeting right here. And when we do this, all of a sudden the errors go away. So this is, one example, and we're going to use this in a real-world scenario in a second, but this is an example of the first thing that we talked about, that it specifies a set of requirements for something to implement, all right? So is that all right for everyone? Everyone make sense of that? Like why we had to put greeting here? It's because test implements iTest. So I'm going to put a little thumbs up in the chat, and as long as you sort of understand that, just click the thumbs up button, and if you don't understand it, then go ahead and click the down button. And if you don't, that's totally fine, so don't be ashamed to click that down button in the chat. All right, looks like we got some thumbs up. We got a thumbs down. All right, cool. So, so JT's living the dream. Hit us with a thumbs down. That's totally fine. Who else hit us with a thumbs down? Becca. Okay, so that's totally fine. So let's go over it for another second. Only because I haven't looked at this yet. Oh, okay. So I'll go ahead and explain it one more time. And then, of course, like if it still doesn't make any sense, then I'd suggest just like watching the recording or reading through here, because reading through here will definitely help you a lot. But the point of this is that with an interface, right, it's not an actual thing, right? With a resource called test, it's an actual value, right? Like we can create it, we can pass it around, we can store it in dictionaries. The thing with interfaces is that they're not actual values. They're abstract like ideas of what a value should be. So in this case, right, like we're never going to actually do anything with iTest, but what we can do is we can make test implement iTest, right? Remember this diagram. The resource here is test, okay? And the interface right here is iTest. And so what we're doing is we're saying the resource implements the interface, and this implements arrow comes from adding this line right here. And this says now all of a sudden test implements iTest. And like we said, what does that mean to implement an interface? Well, it means two things. One, it means to specify a set of requirements for something to implement. So in this case, iTest is saying, all right, we have a public like greeting here, right? And so because that test implements iTest now, it has to have a greeting as well. And if it doesn't, right, if we go ahead and delete these things, it's going to say, hey, resource hello world.test does not conform to the resource interface hello world.iTest. right? And the reason for that, again, is because we need to have whatever's in here inside of here. All right, so hopefully that helps a little bit. All right, cool. So the second thing that an interface means is that it allows you to only expose certain things to certain people. All right, and this is going to be crucial when we talk about the security of our programs and making sure that we don't allow users to call certain things that shouldn't be called. And so what I'm gonna sort of give you as an example is the fact that like let's say you have an NFT collection, right? You have a bunch of goated goats, you have a bunch of Flovatars, you have a bunch of flunks, whatever, right? In the real world, anyone can deposit to your collection. However, not everyone can withdraw from your collection, and that's a good thing, right? Because if I was able to withdraw from your flunks collection, well, I would just hack your account, right, and take all your flunks. However, but I can always deposit to your collection. So if I want to, I can give you a flunk, and that's totally fine. So the question is, how is that handled in code? How do we allow certain things to be called, but not other things to be called? And that's where interfaces come in. So we're going to make a function called create test. All right, and it's going to just do nothing. It's not going to return anything, but we're going to put some stuff inside of here. So what we're going to do is we're going to say let test. The type is going to be an at test. Remember, we went over this in the previous lesson, that this at symbol means a resource. And we're going to say create test, just like that. Now we have to pass in some extra values here. And also, okay, for simplicity, I'm going to change this to name and get rid of greeting so that we don't have to deal with so many variables. But it's still totally fine because this says you have to have a name. This one already has a name, so it works out and all that. So we just got rid of greeting because it's just too much. But let's say the ID is like 0 and the name is Numini. All right, because Numini put a nice thumbs up in the chat. So I don't know what this is saying. I don't know why. Okay, anyway. Yeah, okay, so we created the resource right here. Okay, cool. So what we can do is we can log, let's just log, I don't know, name or test.name. Let's also log test.id, and then we can destroy test. All right, so you'll notice that this doesn't give us any errors. It's totally fine. So if we were to call this function, it would create the test, it would log test.name, and then it would log test.id. Perfect, that's all we wanted. And this is normal, right? This is expected behavior. But what if I told you that we could also create a test, but only allow you to log the name and not the ID? Well, let's see what happens. Let's make another function called public function create restricted test. And we're going to open up a function. We're going to say let test be the same exact thing, test, move in a new resource, so create test. The ID is going to be 0, and the name is going to be June, because June also put a nice thumbs up in the chat. All right. But what we're going to do is we're going to change things a little bit. Instead of at test, right, which is just the whole resource, we're going to restrict it to just the interface. Now, the way you do that in Cadence is you put curly brackets, and then inside the curly brackets, you put the names of the interface. So iTest. All right. Now, something interesting is going to happen when we do that. So let's just get rid of the error by destroying test really quick. All right, so there's no errors now. But let's try and log the variables just like we did right here. So let's log test.name, and that's totally fine. It works well. But let's try and log test.id. Uh-oh, there's a problem. Member of restricted type is not accessible, ID. So the reason it's not accessible is because if we have a test resource that is restricted to iTest, well, iTest has no idea what ID is. So if we try and log name, it's totally fine because it has it in the interface. But ID, it has no idea what you're talking about. So you can't log it, okay? So you can imagine that this is a very simple example, but let's say inside of here, instead of variables, let's say we had a public function deposit function, right? And the deposit function does nothing. Like, it's just going to sit there, right? And so inside of our test, of course, we need to have a public function deposit now, and we're just going to keep it empty because we don't want to actually implement it. But let's say there's a deposit function, and then there's also a withdraw function. So let's say the test resource is like your NFT collection or something, and you have a deposit function, and you have a withdraw function. However, the interface only contains the deposit function, right? So inside of here, let's try and call test.deposit. Oh, it works totally fine. However, if we try and call test.withdraw, it doesn't like it, right? Because member of restricted type is not accessible withdraw, and that's because the interface does not contain the withdraw function. However, if we were to add it here, which we would never want to do, but let's say we did, now all of a sudden the error goes away. All right. And quick note, you may be asking inside the interface, why do we not put the curly brackets? That's because remember, when you're inside of an interface, you don't initialize any of your values. So the name, for example, you don't have to initialize this in an init function, and all the functions, you don't have to open curly braces. But let's say, for example, that withdraw like returned a type. Let's say it like returned a test like that. Then inside here, you'd have to put returns a test, right? But you don't open up the curly braces. You don't do that in the interface. All right? Awesome. So I'm going to put another thumbs up in the chat. How's everyone doing with that? Oh, hey, Davon. I'm glad you made it. Good teaching? Nice. Let me put a thumbs down just in case anyone wants to put a thumbs down. Don't be shy. All right, we got some thumbs up. So Becca put a thumbs up. Awesome. Captain Cook, how you doing? Good? Everyone seems to be doing all right. Nice. Okay, I like that. Okay is positive. All right, so that's interfaces for you. Now, I imagine that inside of this, I think that's actually it for this day. So that's all the knowledge you're going to need to complete your quest for this day, and that should help you. Now, let's just go over one more example. So let me mute that really quick. I don't know where that's coming from. Okay, anyway. Let's say we made another interface, by the way. Public resource interface itest2. Right? Where is it? Noise. Okay, I found it. So let's say we make another interface called itest2. And inside here, we make a public let, I don't know, poop be a string. And then what we can do is we can make test also implement itest2. All right, but there's a problem. Does anyone know what the problem is now? Based on what I taught you about interfaces, what's the problem when I put itest2 here? What is test missing? There's no poop. Exactly. So because test, right? We go back to this diagram. Because test implements itest2, it must have everything that itest2 has. Let poop be a string, and then down here we can say self.poop equals yo. Right? And we're done. Now it's giving me errors. I don't know why. I mean, it shouldn't be giving me errors, but Cadence is the playground is a little bit weird, which is why we are working to make another one. But anyway, yeah. All right, cool. So again, interfaces are just abstract, sort of requirements that your resources can implement to make sure they have certain things, but also to only expose certain things to the public. So one real life example of this, by the way, because I want to try and tie this into like real world scenarios so you can really get a sense of why this is the case. But in a real world scenario, every single NFT contract on the Flow blockchain, they all implement the same resource interfaces. And you may be asking why, but the reason that hopefully you'll understand a little bit better now is because that standardizes the functions and variables that NFT collections have, right? Because if you didn't have interfaces, then what could happen is people could implement their own deposit functions that are called different things, take in different parameters, return different things, and that would be a problem. Because think about an NFT marketplace, right? How would an NFT marketplace know how to read NFT contracts in a standardized way, right? How would they know that GoToGoats and Flovatar, how would they know their individual deposit functions? They wouldn't. But the cool thing is that because both GoToGoats, Flovatar, Flunks, and every NFT collection, because they all implement an interface that's called collection public, this is what it's called in the real world, because they all implement this same interface, they all contain the same functions and variables inside that's inside that interface. So one of them is a deposit function. One of them is a like owned NFTs field that owns a bunch of different NFTs, right? And we'll go over this in the future, but just so you can get an idea of why we have to standardize our resources and collections so that third-party services know how to read our data. All right? Cool. So what we're going to do is, it's sort of like a weird turning point, but we're actually going to take a complete break from resources. So we're actually not going to come back to this in the rest of the workshop today. So I'm just going to go ahead and delete all that. All right, so if we're good to move on, then I will move on, and we're going to make another contract called Hello World. All right, so the moment you've all been waiting for, or, I guess only if you're a complete nerd, but yeah, maybe you're not excited for this at all. However, we're going to start talking about something called access control. So access control is pretty cool, but let me go ahead and make a greeting field. Let's make it an if function. Then inside here, we're going to say self.greeting equals hello world. All right. So throughout this entire bootcamp, from the very single first lesson that I taught you, one of the first things I taught you was that, this is how you make a variable, right? And you have something called pub, but I didn't tell you why we made a pub, which is what we're going to talk about now. But I didn't tell you why we made a pub. And then I told you you can put var or you can put let, right? And let means that it's a constant, so you can't change it, whereas var means you can change it. This is the name that you come up with, and then you put colon space type, right, the type of the variable. But I never told you why we call this pub. And so if you're a complete Cadence geek or a computer science nerd, then you've probably been itching to wonder, or you itching to ask, why do we name this pub? What does pub mean? What we're going to talk about today is that pub is what you call an access modifier, right? An access modifier. And there's a bunch of different access modifiers, in fact. There's pub, there's access all, there's access contract, there's access account, there's access self, and then there's also private and pub set. So there's a lot of them. And we're going to go over what exactly each one of them does. And this is to better understand the security of our contracts. So today we have a big emphasis around security. All right. So what I'm going to do, and what I really encourage all of you to do, is to pull up this diagram that I actually put inside of the bootcamp. This is going to be your best friend when you're talking about access control. It's going to be your best ever friend. And the reason for that is because it perfectly describes, maybe I'm biased, but I think it perfectly describes what each of them is doing if you understand what these things mean, like current and inner, containing contract, all this stuff. So once you understand what these mean, then you'll be able to go back here as a cheat sheet and understand this a lot better. So you'll notice that there's this chart, right? And there's a bunch of rows that start with let, and there's a bunch of rows that start with var. We're actually going to completely ignore let. And the reason for that is because let, like I taught you already, is a constant. So you can never change it. And so when we talk about things like write scope and read scope, which is where you can read the variable and where you can change the variable, or in other words, write the variable, it's not that interesting when we talk about let because it's a constant. So there is no write scope, right? You can't change it. So that's why on the right-hand side, you'll see that for every single row that has let, you'll see the write scope is none. And that's because let is a constant. You can't change it or write it. So we're going to focus more on the var rows, because if you understand the var rows, then you'll also understand the let rows. So we're just going to skip right to here. Okay. So let's start with something that we know. We know something called pub. Now, the cool thing, I don't know if this is cool, but maybe it'll help make things simpler, is that pub is the exact same thing as access all. So if you ever see access all, that is quite literally the exact same thing as putting pub. Now, you'll notice that pretty much no Cadence developer ever puts access all, and well, the reason for that is because it's verbose, it's like annoyingly like written, and it's much easier just to put pub. So anytime you see those two, just know they're the same, which is why, if you go to any of these other contracts, you'll see that the Flow Playground always uses access all, and you notice that one of the first things I do is I always change it to pub. It's because it's the same thing and it's easier to read, in my opinion. All right, so just know that. Okay, so let's go over what does pub actually mean. Well, let's search through here. We're in the var columns, and we're going to go right to here. So pub, this is where we want to be, and it's the same thing as access all. Sweet. Okay. So this first column, or this third column here, is read scope. Now what that means is this is where you can read the variable, all right? This is where you can read it. And you'll notice that here it says all. So what does that mean? Well, all means that we can read this everywhere. We can read this in the contract. We can read this in a transaction and script. We can read this inside of anything we want, okay? So all. Now, if I deploy the contract, if I go to a script and let's import hello world from 0x01 and return a string here, and we're going to return hello world dot greeting. Now, if I execute this, you'll see it says hello world, right? So we took this variable, it's public, so its read scope is all, and we can read it outside of the script, which is great. And we can also read it inside the contract. So we had a public function called like say hello. We could basically just log self.greeting, and you'll notice that right here we're reading the greeting, so we can truly read it everywhere that we want. All right, but let's go ahead and look at the write scope. So what is the write scope for public? Well, it's current and inner. So this is where things start to get a little confusing. And spoiler alert, this is definitely a little bit of like a mind boggle. And it's gonna take you a second to grasp this, but let me try and draw this in real time to help you understand. So think about this as the contract. Okay, so this box is a contract. Now we're defining pub var greeting to be a string inside the contract, right? Does this make sense to everyone so far? So public var greeting string is inside the contract box. Now, when we say that something has all, that means that we can read it inside, we can read it outside in, let's say, a transaction or a script, right? So that's what that means. However, current and inner, right? This current inner, that means we cannot read it outside. We can only read it in the current, which is at this level, and inner scopes. So anything within. All right. Let me just undo those really quick. Okay, cool. So what that means is that if we change this, so that's the write scope, right? That's where we can write it to. So knowing that, right? If it says that for public, the write scope is current and inner, are we going to be able to change greeting inside of a transaction? Any guesses? You can just type yes or no in the chat. Seems like people are scared. Beck is scared. Captain Cook is scared. You're banned from the boot camp if you get it wrong. I'm just kidding, of course. All right, let's talk about it again. So here is our greeting, right? This is our variable. So I showed you that within this diagram, right? You can think of the contract as like a box, okay? And our variable lives inside of this box. Now, there's like when we say all, right? We can read it from everywhere. That means we can read it within, which is this arrow, and we can read it outside, which is this arrow. So we can truly read this variable everywhere. However, when we think about the write scope, it says the write scope is current and inner. So current and inner means at this level, at the current level, and within. So we cannot, right? This is not in the current and inner scope. This is outside. This is outside of it. So when you're reading these descriptions, think of each one of these levels as like a box. So we can't read it outside the box. It's only current and inner. So you guys are right. So the answer is no. Yep, exactly. So the answer is no. So let's go ahead and test that. So in a transaction, could we say hello world dot greeting equals sup? Idiot. Nope, we can't. Cannot assign to greeting field has public access, right? So it doesn't work. We can't do it. However, the read scope, as we said, is all. So in a script, we could easily read it. And we could also read it in a transaction if we wanted to, but it doesn't really. Yeah, like we could read it here too. All right. Awesome. So let's try a different one. Let's try. I keep bouncing between these, but let's try this one called public set. All right. Public set. So public set, for lack of a better term, is the most dangerous access modifier. And the reason for that is because it's the least secure by far. So what public set does, let's look at it again, is the read scope is all. So it's exactly like public or access all, right? The read scope is all. But notice the write scope is also all. So do we have any guesses? Are we going to be able to change greeting in a transaction now? JT says yes. Numity says yes. And Chico says yes. So let's try it. So if we were to go ahead and deploy this contract, go to our transaction. Oh, now it's totally fine. So now we can change it. Okay, so that's what that means. And again, this is really dangerous because you can imagine that if you have a contract and you have data inside of it, right? You have some data. Now anyone can theoretically run their own transaction and change that data. So anyone could go into a transaction, call it, sign a transaction, send a transaction, and change your data. So you never really want to use public set except for very, very rare circumstances. But in general, I would try and stay away from this. And if you ever find yourself in a situation where you're forced to use this, then my piece of advice is that you're probably doing something wrong in the first place. But that is good. It is good to know about. And there are very rare cases where it would be beneficial. Okay, so we just covered public set and public. Let's go to access. We're going to skip access account, and I'll tell you why in a second. But let's go to access contract. So access, let's change this to access contract. All right. So access contract says that the read scope is current, inner, and containing contract, whereas the write scope is current, inner. Okay, so let's talk about the read scope. So if the read scope is the current level, inner level, and containing contract, who thinks we're going to be able to read greeting in a script? Can we read greeting in a script? So Numity and JT both say yes. The answer is no. Because let's read this again. Access contract, right, is current, inner, and containing contract. Right? Current, inner, containing contract. So we think of this as a box, right? This is the box, and this is now access contract. All right? So the current level is this level. The inner level is everything inside of here. And the containing contract is this box. Does that include a transaction and script? No, it doesn't. So we can't read this variable in a script now. We can't read it here. And very similarly to public, the write scope is also current and inner. All right, so we also cannot change this variable in a transaction either. We can only change it within this contract. All right. It is tricky. It is very tricky. Yeah, it is very tricky. All right. So if anyone's confused, I mean, I know a lot of you are confused, but if you are confused, just let me know so that I can either go slower or review it or not. Because if I don't see any questions in the chat, I'm just going to assume that everyone's doing all right. Okay, cool. So assuming everyone is doing good. So now let's look at access self. So access self is the read scope is current and inner, and the write scope is current and inner. So you'll notice that it's actually the same exact thing as access contract, except for this one missing line. In the read scope, the containing contract. So what does this mean? Well, we're going to dive into a more complicated example now, and we're actually going to walk through the quest together so that you all can hopefully walk away feeling confident about this. And even though we're going to solve the quest right now, I would still recommend doing it on your own, 100%, because I think it'll help you a lot. Okay. So with that being said, let's do this quest together. So this quest this is by far my favorite quest. It's actually like really fun. And it's almost like a puzzle game. So I think it's actually really cool. And yeah, so let's go ahead and do it. Okay. So the quest is, for today's quest, you will be looking at a contract and a script. You will be looking at 4 variables, A, B, C, and D, and 3 functions, public func, contract func, and private func, defined in a contract called sum contract. In each area, 1, 2, 3, and 4, so area 1, area 2, area 3, and area 4, I want you to do the following. For each variable, A, B, C, and D, tell me in which areas they can be read, read scope, and in which areas they can be modified, write scope. For each function, simply tell me where they can be called. So we haven't really gotten to functions yet, but let's stick with the variables. Okay. Again, it's almost like a puzzle game. So this is the first area, area 1. So we're tasked with, in this area, which variables can be read and which variables can be changed, right? This is write scope, and this one is read scope. All right. So let's go to the first one, A, right? So let's just take a quick look at what the contract looks like. So the contract has a struct right here, right? This is a public struct called sum struct. And inside the struct, we contain some data and some functions. And then we also define a resource, right, called sum resource. And then we also define some random function, and then some other random function right here. And then we set self.teststruct to this sum struct type right here. Okay. So again, we have a variable called teststruct, an actual struct type, a resource type, and then a function called create sum resource right here. All right. So this function right here, this area right here, this is inside of a function called struct function inside of a struct. Okay, that's where we are, and all these variables are defined inside the struct. So let's go ahead and look at this. So variable A has access modifier public set, right? Public set. So going back to our diagram, public set has read scope of all. So if we think about this, let's actually draw another diagram. Let's actually draw another. I think it'll actually be helpful if I draw a diagram here. Delete, delete, delete. Okay, so inside this box, we have another box called this. So this is the sum struct, right? Like just like that. And then we have another box called sum resource. So what I'm drawing here is this struct, the sum struct, and then the sum resource. So this box and this box. All right. And inside sum struct, we have A, B, C, and D. So I should probably make this bigger. Oh, oops. Make this bigger. Let's move this down more. Oh, not that. I want to move this one down. And we're going to make this bigger. And inside here, we have a variable pub set. Let's just say A. A, B, C, and D. And then inside this struct, we have a function called struct function. just like that. All right, so hopefully this box model gives you a better idea of what we're dealing with, right? So we have a contract. Inside the contract is a sum struct box. So a sum struct box. Inside the sum struct box, we have 4 variables, A, B, C, and D, right? So I'll put this right over here, A, B, C, and D. And then inside, again, we also have this thing called the struct function, which is right here. And then inside of here, this is where area 1 is, right? So this is area. Let me make this blue. No, not that one, blue. Area. Oh my god. Everyone's gonna start laughing again. Area 1. Alright, don't laugh. Becca says I'm such a visual learner. Oh, I'm so glad. Okay, I'm really happy this is helping. Sorry, I thought I was like going off on like a really weird tangent. But I hope this I hope this is helping. So what we're talking about right now is area 1, okay? No, not 51, just 1. Alright, cool. So what we're gonna talk about, all right, so now that we set up this whole box, let's talk about this. Why do I keep going back to this? Okay, now that we're in this box, let's talk about variable A. Okay, so variable A is public set, and public set says that the read scope is all. So who thinks that we can read area 1, read A inside of area 1? Becca says yes. And even if you think you're totally wrong, just type it in the chat because it actually really helps you learn if you get it wrong. Because if everyone just types it and they know they're right, then we're not gonna be able to help the people that are behind. Okay, everyone says yes, perfect, you got it right. Okay, so far we have A. All right, now let's go to B. B is public. Okay, so B has a read scope of all. So pretty similar answer, but who thinks we can read B inside of area 1? Yes. Yes. Yes, everyone says yes. Perfect, great job. So we can also read B. All right? Woohoo! That's awesome. All right, now let's go to C. So C has a read scope. This is access contract, okay? C has a read scope of current, inner, and containing contract. Let's go to our box again. Is area 1 in the current or inner levels of C? Yes? Becca says yes. Let's see what Crypto Chica says. Crypto Chica says no. JT says nodding. So the answer is yes. Becca got it right. The answer is yes, and so did JT. So the reason that it's yes, and Crypto, I'm glad you typed no, but the reason it's yes is because if we go back to our thing again, right, the read scope is current, inner, and containing contract. So the one that's going to save us here is this current and inner part, or mainly this inner part, okay? So if we go to our box model, C is right here. And when we talk about the lower level, right, because each box is a lower level, right? So C, or area 1, is in a lower level. So it's inner. It's within C. It's within C's range. So we're going down a level. So that's totally fine. Because, again, this inner part, right, the inner part is what makes it good. So the answer is we can read. So we can read C. All right? Cool. So then we go to D. And D is access self. So D is access self. And D says access self is current and inner. So any guesses? Is this yes or no for read scope? Nobody says no. Tabcool says yes, yes, yes. So the answer is yes. And again, it's because, it's current and inner. So because D, or because area 1 is in the inner scope of D, it works, right? We go down a level. Numini says I suck. It's okay, Numini. It takes a second for sure. But we go, yeah, we do love you. We love you, Numini. Hearts in the chat. Hearts in the chat. We're all in this together. So we go down a level. So Numini, I hope, does this make sense why it's yes? Because we're going down a level, so it's inner. And again, inner is the access self one. And I'm loving the participation, guys, by the way. This is so helpful for me. The illustration is very helpful. Oh, I'm so glad. Okay, I'm really happy this is helping people. Okay. Cool. So great, we did that. And we have to speed up a tiny bit only because we have 3 other areas to go. Okay, but now we're going to talk about right scope. All right. So let's talk about right scope. We're going to kind of speed through this one, but the right scope for public set is all, right? And A is public set. So who thinks we can write to A in here if the right scope is all? Yes, right? So the answer is yes. Perfect. Great job, Becca. Awesome. And again, it's all, so we already know the answer to that. And the cool thing, by the way, is that once you identify, Numity says no. So the answer is yes, Numity. And it's because again, it's all. So if if A is here, then area 1 is included in the all scope, right? It's everywhere. Oh, JK. Okay, good. Nice. So then let's go to the next one, which is B. B is pub. So let's go to B. And this is current and inner, right? So who thinks we can write B in this spot? Current inner. Becca says yes. Yes, yes, yes. Great. And to save us some time, access self and access contract are also both current and inner. So for all 3 of these, the answer is yes. So it's A, B, C, and D. Sweet. Simple, simple, simple. Now that we got the box diagram. Nice. All right, so that's area 1. Now where's area 2? Area 2, oh, so this is where things get complicated. So area 2, let's expand this a little bit. Is over here. So look, this is where things get a little tricky. Right, and this, we're going to call this one area 2. Right, so the thing about this now is that A, B, C, and D are defined inside of some struct. So this area is no longer in a downward level. It's in a outward, like we have to go outside of this, over to here, and then inside. So this outside step is going to cause problems. Okay, so we'll see that in a second. So let's go to the first one. First one is public set. Okay, so let's go to public set. The read scope is all. So who thinks that that we can read A inside of here? Yes, 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 yes. And what I'm going to do is, so for the rest of this workshop, whenever we see all, the answer is, well, always yes, right? Because if it's all, then it quite literally includes everything. So for everything that's all, we're always going to say yes. Okay, so I'm glad that everyone's catching on to that. So let's go ahead and put these both here. And so which variables can be read? Answer is A. All right. So let's go to the next one. The next one is public, which is B, and we see the read scope is all. So the answer for this one is also yes. Okay, B. Now let's go to C. So C is access contract. Now access contract has a read scope of current, inner, and containing contract. Hint: containing contract. So in this box, is area 2 in the containing contract? That's a yes. Great. Nobody, stop trolling. I know you're trolling at this point. The answer is yes. So perfect, right? So area 2 is within the containing contract, and that's where this part becomes really crucial, the containing contract part. That's where it becomes really, really crucial. So we're going to put C here. All right, cool. Now the next one is access self. Now access self is current and inner. So is area 2 in the current and inner scope of D? No. No, 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 it's not. It's definitely not. And I bet Numity's going to say yes. All jokes, Numity, all jokes. The answer is no. Great job, great job. So for this one, it is no. So we're not going to put that here, okay? So now we're going to go to the right scope. All right. So for the right scope, yeah, let's go to the right scope. I'm back. I love that. Let's go to the right scope. So again, first one is public set. Answer is all. So obviously yes for right scope. Let's go to the next one, which is public, current, and inner. Well, we already all decided that this does not include the current and inner scope. So for the rest of these, right, public, which is current and inner, contract, current and inner, self, current and inner, right, all these are a no. So we can't do it, right? Because we already decided that area 2 is not in that current and inner scope. So GG, not allowed. Cool. Let's go to area 3. So we're in area 3 now, and let's go back to our diagram. So now we're in area 3, which is, what's the function called? Quests are fun. So we're going to make a new little box over here called quests are fun. And this is going to be, let's make it, I don't know, green. Area 3. Sweet. So now we're in this area. So again, look at where we are. We have to go out, right? That out step is a big problem. Down and in, right? So remember that out step is where the problem is going to come in. So we're here now. Which variables can be read? Well, obviously, for public set and public, it's both all. So for A and B, it's an obvious yes, right? Because we decided all is always going to be yes. And then we talk about access contract. So access contract is current, inner, and containing contract. So who thinks that area 3 can be read by C? Yes, yes. Perfect. Great job. So C is included. And then D, which is access self, is current and inner. Is this in the current and inner scope of D? Scripto Chica says no. Oh, the question is D or is area 3 in the current and inner scope of D? Can we read D in area 3? So no, no, no. Great job, everyone. The answer is no. So we cannot read D here. All right. Now let's go to right scope. So obviously for public set, the answer is all. So we're going to say an obvious yes to that one. And then the rest of these are current and inner, current and inner, current and inner. And because we just decided that area 3 is not in the current and inner scope of D, then they're not included. So that is the answer for area 3. All right, so one last one. We're going to go to area 4, which is right here. And let me actually, I think it's actually in the quest. So yeah, it's right here. So this is now the quest. Let me just deploy this contract so we don't get errors. Go to the script. Now we're here. This is area 4. And let me just copy and paste our little answers right here. Okay. And all right. So now we're here. All right. So which variables can be read? Well, let me draw the little box. So the box we're in now is over here, which is really interesting. So this is actually, I'm going to delete this for a second. We're now inside of a script. Make this black. And this is, what color? Northwestern colors. Love it. Area. I'm going to screenshot this afterwards because I think it's really helpful, actually. I think. I don't know. Okay. So here we go. Here's area 4. So now we're inside of area 4. Okay. And again, this is outside the contract. So who has any guesses for which ones can be read? So I guess instead of going individually, I'll just ask all of you to list the ones you think can be read in area 4. Let's go back to here. Which ones can be read? Remember, this one is public set. This one's public, access contract, and access self. Tabcol says A and B. Becca says A and B. A and B. Great job, everyone. So let's see why. So for public set and public, the answer is obviously all, because it's just all. For access contract, it's current, inner, and containing contract. So because we're no longer in the containing contract, it doesn't include C anymore. And obviously, it doesn't include current and inner. So the obvious one is A and B. Now, for this one, let's go to right scope. So we're in a script, and let's see. So A is public set. So can we write to A in the script? Becca says yes. Nobody says yes. What do you think, Tabcol and Crypto Chica? Yes. Ah, Tab Cole got it. It was a trick question. It's a trick question. So the answer, I love getting people with that. Every snowmobiles knows this. Every single boot camp, the only moment I'm like really excited about is this exact moment because I trip everyone up. Ha ha ha! Get wrecked. Woo! Get wrecked. Get wrecked. Get wrecked. I love this moment. I feel like such a champion. So the answer is, well, technically yes, but no. The answer is no. So you cannot write A inside of a script because it's a script. So all you losers who thought you were smart for a second, you're not. You're an idiot. Just kidding. I love you all. You can't write to A in the script. So the obvious answer for the rest of these then is no. So you can't write anything in a script. So trick question, get wrecked, and it's all downhill from here. LOL. Anyways, that is access control. So all of you, wow, I mean, I'm actually really proud of all of you. You did a great job. And as you can probably tell, I get most excited about this lesson. It's really fun for me, and it's like a little puzzle piece, so it's super fun. And one thing that we didn't get to talk about was, oh yeah, so quick note, by the way, access self is the same exact thing as private. So just in case you were wondering, in the same way that public is the same thing as access all, private is the same way as access self, but it's weird because you'll never see a cadence dev write access all, but it's really strange because you'll never see a cadence dev write private. They always write access self. So I don't know why they do that. I literally have no idea, but you'll always see access self. You'll never see private, but you will always see public and you'll never see access all. So don't know why they do that, but that we do that because I guess we're quirky. So that's it. And the last thing I'll talk about is access account. I didn't get to talk about access account, and the reason for that is because Playground makes it really difficult for me to talk about access account. Now you'll notice if we look at the read scope, access account is current, inner, and other contracts in the same account. So that seems weird. If we go back to the Playground, you'll notice that so far throughout this entire bootcamp, we usually associate every account with one contract, right? Like account 1 has this contract, account 2 has this contract, etc., etc. However, in the real world, right, like in the actual mainnet world, every account can have any amount of contracts they want. And I'll show you an example of that. So this is what we call the flow view source, and this shows you all the contracts inside of an account. So you'll notice that much like this is a contract in account 1, these are all contracts, all these 5 are all contracts in account 0x921EA449, whatever, right? So in the real world, you can actually have multiple contracts in an account. So what access account means is that the read scope is current, inner, and other contracts in the same account, which is really cool. So that means that in Flowvatar contract, if we have an access account, oh look, they have one right here, access account, that means you can access this variable in all these other contracts too, right? But again, it's hard to talk about this in the Playground because they only allow you to deploy one contract per account, but in the real world, that's not the case. So that's all I wanted to say about that. And with that, I'm officially done with my spiel, and you're all happy to enjoy the rest of your Fridays. Love you all very much. I'll stick around for any questions, and yeah, have a wonderful Friday, everyone. I was wondering about that myself, found a reference to private on the flow docs and couldn't find anywhere in the actual examples. Emerald Playground or whatever the name, here we come. L is probably the one thing along that will make the new version we were working on so much better. Totally agree, was. I'm so excited. So excited. Emerald Playground, I love. Yeah, we'll have to, what should we call it? Like Emerald Playground, Emerald, I don't know what we'll call it. That's always the fun, right? Is figuring out what to call it. Can we please call it that? Emerald, yeah, we'll call it Our Playground is Better. Oh my god, I'm not kidding. That is genius marketing right there. Everyone would use it. Everyone. Yeah, we could also call it Theme Park, Emerald Theme Park. Or, oh, this is gonna be so cringe. But I noticed the EME. Sorry, that's cringe. I didn't mean it. Had to put it though. Anyways, yeah, I took one look at it. I had to put that. Anyways, that's all I have for today's lesson. Thanks everyone. And what I'm gonna do is, because all of you found this so helpful, I'm actually going to screenshot this and upload it to the I'm gonna upload it to the lesson, so all you can see it. Save as. I'm gonna save it as thing. I don't know. Cool. That's it. I'm gonna upload this. Oh, float. Thank you. 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 Totally forgot. Oops, my bad. Oh, I'm not logged in on this account. Okay. I'm on a different computer, so I guess I'm not logged in. Oopsie. Let me go to my email.